There's a star in our sky that's dying. It's massive, unstable, and closer than any other star of its kind. Astronomers agree it's going to explode. The only question is when. Some say it could be tomorrow, others say we've already missed it, and we're just waiting for the light to arrive. When it happens, the explosion will be visible from Earth. But what else comes with it? Could it affect our atmosphere, our satellites? Is there any real risk? Let's find out. Betelgeuse isn't just another star in the sky. It's one of those rare cosmic landmarks that manages to be both famous and misunderstood. Most people have seen it without realizing what they're looking at. It sits at the shoulder of Orion, glowing faintly red. Always there, steady and constant. Or so it seems. But Betelgeuse isn't steady, and it's definitely not constant. The star's variability and massive size make it a prime target for astronomers studying stellar evolution. This thing is a red supergiant. That title alone already tells you a few things. It's big, it's old, and it's not going to live much longer. But when you hear the word big, your brain probably imagines something like a large planet or a bigger version of our sun. That's not even close. If you placed Betelgeuse where our sun is, its outer surface would stretch beyond the orbit of Mars. Some estimates say it could even reach Jupiter. That's not just a bigger sun. That's a star so massive that Mercury, Venus, Earth, and Mars would all be inside it. Not scorched, not orbiting gone, vaporized, absorbed into its outer layers. It's about 700 times the size of the sun. Not 700%, 700 times. You could fit over 1.6 billion suns inside it. And yet, it's not particularly heavy not compared to other stars. Betelgeuse has somewhere between 10 to 20 times the mass of our sun. Still a lot, but for its size, it's surprisingly lightweight. That's because it's puffed up, bloated from the inside. Its outer layers are loose, stretched thin, like a balloon that's about to pop. And that's exactly the problem. When stars get to this point, they don't last long. They burn through their fuel at a crazy rate. That red glow we see, that's a sign of age. It's cooler than our sun, but only because its outer layers have expanded so far out that the surface temperature dropped. Inside, it's a pressure cooker. The core is running out of things to burn. First, it went through hydrogen, then helium. Now it's chewing through heavier elements, climbing the periodic table like a countdown. Once it hits iron, that's it. Iron is the end of the line. The star can't get any more energy from fusing it. And without that energy pushing outward, gravity takes over. The whole thing collapses in on itself, and in a fraction of a second, it explodes. That's where Betelgeuse is headed. Not someday, not maybe. It's a red supergiant near the end of its life. The only uncertainty is the timeline. It could go supernova tomorrow, or it could take another 100 years. And because it's 640 light-years away, even if it explodes right now, we wouldn't see it until the year 2665. But there's another detail that makes this even more interesting. Betelgeuse is a variable star. That means it changes. It pulses. It gets brighter and dimmer over time, almost like breathing. Most red supergiants do this, but Betelgeuse does it dramatically. What makes Betelgeuse special is that these brightness changes are visible to the naked eye if you observe it over weeks or months. Patient skywatchers can track these changes by comparing Betelgeuse's brightness to nearby stars like Rigel or Aldebaran. That's part of why its recent dimming caused so much confusion. It does vary, but this time it dimmed way more than expected. It dropped to an unusually faint magnitude, sparking widespread interest enough to make scientists think something major was happening. And maybe it was. Or maybe that's just Betelgeuse being unpredictable again. That's what makes it so fascinating. We're not just looking at a big star. We're watching a massive, unstable object live out its final moments on a scale so large it's hard to fully grasp. We're not observers of a steady thing. We're watching a slow-motion collapse, a countdown in cosmic time, and we still don't know when the clock runs out. We'll get back to space in a second. But first, something actually did explode here on Earth. Not a star, a Supreme Court decision. You might have seen it. The Trump administration just got the green light to lay off nearly 400 employees from the Department of Education. Some headlines called it the Supreme Court's latest gift to Trump. Others reported it plainly, saying, "Justices allow layoffs at Education Department." Same story, but completely different takes. And that's exactly why I use Ground News. It's a platform that shows you how every side of the political spectrum is reporting the same news, left, center, and right, all laid out side by side. For this ruling alone, Ground News tracked nearly 600 articles, and you can literally see how the framing shifts depending on the outlet. It's one of the few ways to cut through the noise and actually understand what's going on. They also have a browser extension, which is super useful. Whenever you're reading an article online, it pops up and shows you media bias, source transparency, and whether you're stuck in an echo chamber all in real time. If you want the full picture, not just what your feed decides to show you, scan the QR code on the screen or go to Ground News Fexel. You'll get 40% off their Vantage plan and full access to everything I just showed. The link's also in the description. In late 2019, something strange happened. Betelgeuse began to dim. Not just a little. Not the usual slow pulse that astronomers were used to. This time it dropped hard by over 50%. And it happened fast. At first, it wasn't a big deal. Betelgeuse had always been a variable star. Astronomers knew it changed brightness over time. But this was different. In just a few months, it had gone from one of the brightest stars in Orion to barely making the top 20. It wasn't subtle. Anyone who knew the sky well could tell Betelgeuse was fading. The internet did what the internet does. People started asking the obvious question. Is this the beginning of the supernova? And honestly, even some scientists weren't sure because red supergiants don't exactly send an email saying, "Hey, explosion incoming." But this level of dimming, this sudden steep drop, it looked like something big was happening. Observatories around the world, and even in orbit, were pointed at the star. The Hubble Space Telescope caught signs of something odd, a huge blob of material, dust and gas, moving away from Betelgeuse. It looked like the star had sneezed. And not just a puff, more like a giant eruption of its outer layer. So what was going on? One theory was that Betelgeuse had ejected a chunk of its, literally blown off a massive piece of its outer shell. That material then cooled and condensed into dust between us and the star, blocking the light. In other words, Betelgeuse didn't dim because it got weaker. It dimmed because it put up a curtain of its own, making a dust cloud, temporarily obscuring part of its light. Another theory pointed inside. Maybe the star's surface temperature had actually dropped. Maybe something shifted deep within, throwing off the usual balance. Red supergiants are already unstable, and convection inside them can cause massive surface changes. Cooler spots, brighter patches, even distortions in shape. Or maybe it was both. An internal change triggered an external ejection. A sudden shift inside Betelgeuse caused part of the outer layers to get flung off, which then formed dust that blocked the light from reaching us. Either way, for months, the astronomy world held its breath. And then, the star brightened again. Slowly, it returned to normal. The brightness came back. The panic faded, and Betelgeuse went right back to doing what it always does. Pulsating, glowing, being enormous, and staying unpredictable. But even though it didn't explode, that whole episode left a mark because it showed us something we hadn't really seen before. Betelgeuse is more active, more complex, and more unstable than we thought. And if it can randomly throw off part of its outer layer, if it can dim by half in just a few weeks, then the idea of it suddenly going supernova doesn't feel that far off anymore. And here's the eerie part. If it had exploded back in the 1300s, this is exactly the kind of thing we might see right before the flash of light hits us. That moment of weird behavior, that final hiccup before the end. So now we're left with a question that no one can answer for sure. Was that dimming just random chaos? Or was it the first visible tremor of something we haven't seen yet? Here's where things start to mess with your sense of time. When we look at Betelgeuse in the night sky, we're not seeing it as it is now. We're seeing it as it was, about 640 years ago. That's how long its light takes to reach Earth. So the star you're looking at tonight, that soft red glow, is a 14th century postcard finally arriving in your mailbox. this isn't just a fun space fact. It's a serious scientific limitation because it means we have no real-time information about Betelgeuse. None. The star could have exploded centuries ago, and we simply haven't received the update yet. It's like watching a live feed with a 640-year lag. This has led to a strange kind of suspense in the astronomy world. Every time something weird happens, like the dimming, people start to wonder, is this the beginning of the end? Or is the end already over? If Betelgeuse went supernova in, say, the 1380s, then the light from that explosion would be reaching us right around now. And when it does arrive, it won't creep in slowly. It'll appear in the sky with a flash so bright it could outshine the full moon. You'd be able to see it during the day. At night, it would cast shadows. It would linger in the sky for weeks, maybe months, then slowly fade. But here's the mind-bending part. If that happens tomorrow, we're not witnessing something happening. We're witnessing something that already happened hundreds of years ago. We're just finally catching up. This also means that trying to predict Betelgeuse's explosion is kind of pointless. You can model probabilities, you can observe its activity. But if the explosion has already occurred, there's nothing left to predict. You're just waiting for the light to arrive. That's why scientists talk about Betelgeuse in terms of probability windows. Some say the explosion will likely happen within the next 100 years. That sounds far away, but in cosmic terms, that's nothing. That's a blink. Stars like Betelgeuse don't stay in the red supergiant phase for long. It's a short, unstable, dramatic end to a very long life. We just happen to be born at the exact right moment to see it. Or maybe the exact moment after it already ended. Either way, Betelgeuse is a reminder that the sky isn't showing us the present. It's a gallery of ancient light, a history museum glowing in real time, and one of those glowing dots might already be gone. So, let's say it finally happens. The explosion we've all been waiting for. Betelgeuse goes supernova. What exactly does that look like? It starts deep inside the core. As the star burns through heavier and heavier elements from helium to carbon, neon, oxygen, silicon, it eventually hits a wall, iron. And iron is a dead end. You can't get energy out of fusing iron. Instead of giving off energy like the lighter elements, fusing iron consumes energy. Once a star starts producing iron, the clock is basically out of sand. At this point, the core becomes a dense, iron-rich ball surrounded by collapsing layers of gas. Gravity, which the star had been fighting off for millions of years with heat and radiation, suddenly wins. The core can't hold up the weight anymore. It caves in catastrophically. In a fraction of a second, the core implodes. The outer layers collapse inward, then rebound violently off the ultra-dense core. That rebound sends out a shock wave so intense it rips the star apart from the inside out. That's the explosion. That's the supernova. To us here on Earth, it would be a light show beyond anything we've ever seen. First, we get hit with a wave of neutrino subatomic particles that fly out at nearly the speed of light. These would reach us even before the light does, but we wouldn't notice them without specialized detectors buried underground. They just quietly pass through your body, through the Earth, like they weren't even there. Then, hours later, the real blast would arrive: light, radiation, and energy from the explosion itself. Suddenly, a new star appears in the sky. Except it's not a star. It's the death of one. And it's bright. Really bright. Brighter than a full moon. Maybe even bright enough to be seen during the day. You'd look up and see something unfamiliar, something glowing in a place that usually just holds stars and emptiness. At night, it would cast shadows on the ground. People who don't follow astronomy would panic. It might even cause disruptions not from the radiation, but from the headlines, the conspiracy theories, the fake doomsday predictions. But in reality, Earth would be fine, as spectacularly fine, because Betelgeuse is far enough away, 640 light-years, that we wouldn't be in any danger. No blast wave, no lethal radiation, just an epic view. And it wouldn't be over in a flash. Supernovae linger. The bright light would stay visible for weeks, maybe, even months, gradually, fading as the debris cools and spreads. Telescopes would lock on, recording every moment, studying the physics of a dying star in real time. And after the glow fades, something even stranger begins. The core that collapsed doesn't disappear, it transforms. If there's enough mass left, Betelgeuse could become a neutron star, a city-sized ball of matter, so dense a teaspoon would weigh more than a mountain. Or, if the star's core is heavy enough, it could collapse into a black hole completely invisible, surrounded by the remnants of the star it once was. That's what happens when a red supergiant dies. It doesn't just vanish. It leaves behind a scar in space, a kind of cosmic memory that tells you something massive was here. And when it's Betelgeuse, the entire world will see it happen. Like a message from the past finally catching up to us. But until that day, we're just staring at a glowing dot in the sky, wondering, is today the day? Let's get this out of the way. If Betelgeuse explodes, it's not going to kill us. It won't melt the atmosphere. It won't fry satellites. It won't do anything close to that. But let's break down why. First off, distance. Betelgeuse is about 640 light-years away. That's far. Very far. To put that into perspective, the Voyager 1 spacecraft, the farthest human-made object that's been traveling for nearly 50 years and hasn't even reached one light day. Betelgeuse is over 230 million times farther than that. And when it comes to supernovae, distance is everything. A supernova releases an enormous amount of energy, yes, but most of that energy spreads out equally in every direction. It's like blowing up a balloon. The farther away you are from the surface, the more stretched out and harmless it becomes. So, even though Betelgeuse will unleash more energy in a few seconds than our sun will in its entire lifetime, that blast will be diluted by the time it gets here. You'll hear people bring up gamma rays. What if Betelgeuse sends a gamma ray burst? That sounds scary. Gamma rays are high-energy radiation, and if one hit Earth at close range, it could absolutely damage the atmosphere, destroy satellites, or worse. But here's the thing, gamma ray bursts are directional. They shoot out in narrow beams like a flashlight, not in all directions. And even then, not every supernova produces one. Only certain, types specifically, collapsing massive stars that form black holes under the right spin conditions, create a gamma ray burst. Even if Betelgeuse did, the odds of one being perfectly aimed at Earth are practically zero. Plus, a gamma ray burst capable of harming Earth would need to happen within about 30 light-years. Betelgeuse is 20 times that. It's not even close to the danger zone. So no, Betelgeuse is not a threat to life on Earth. It's not going to cook the planet. It's not going to set the sky on fire. It's going to be a light show, a spectacular, harmless light show. Now, could it affect things in space? Maybe slightly. Some satellites, depending on their sensitivity, might pick up bursts of high-energy particles. Space telescopes could register spikes in radiation, but nothing that they aren't built to handle. The sun still bombards Earth with solar flares that are way more intense than those we deal with all the time. As for life on the surface, you won't notice anything unusual beyond what you can see with your own eyes. No radiation sickness, no sudden spike in temperature, just a new bright spot in the sky. That's it. If anything, the real impact will be psychological, cultural, emotional. Seeing a star explode, watching it unfold over days and weeks would be a global event. People would talk about it the way previous generations talked about eclipses, comets, or even landing on the moon. It would be history, the kind you could look up at every night and actually see. And for astronomers, it would be a once-in-a-lifetime chance to study a nearby supernova as it happens. No guesswork, no reconstructions. Just raw data from a real explosion. In real time. So, while Betelgeuse exploding might sound scary, the truth is we couldn't ask for a better seat. We're close enough to witness it, but far enough to survive it. A front-row view of a cosmic event without the consequences. So, where does that leave us? We've got a star so massive it would swallow half our solar system. So unstable, it's constantly shedding pieces of itself into space. So far away that we're looking into the past every time we see it. And so close in cosmic terms that when it finally goes, we'll see it with our own eyes. It's rare to have a front row seat to something this huge. Rarer still to know it's coming, but not when. That's what makes Betelgeuse feel different from everything else in the sky. It's not just a star. It's a silent countdown. Maybe days, maybe centuries, maybe it already happened. And in the middle of all that uncertainty, there's one thing that's guaranteed. The moment it explodes, it'll change how we see the sky forever. Not because we'll be in danger, but because we'll be witnessing the death of a giant, live, unfiltered, and right on schedule 640 years late. So yeah, keep an eye on Orion's shoulder just in case tonight's the night.